Hello everyone, welcome to TalentSprint. So in this session of physics, we shall discuss about the topic called waves. So are you ready? Let's get started. So waves. So what do you mean by a wave first? So wave is nothing but it is a disturbance in a medium that carries energy without a net of movement of particle. So most of you think that suppose there is a particle A, because of wave, the wave will carry that particle to a place to B. So most of us think that waves will carry the particles, but it will not happen. It will carry only the energy. Suppose there is a wave like this. Okay, suppose there is a particle called A here in the wave. So when I am carrying the energy, the particle will change its position to B. Same particle will move downward. So wave will be just carrying the energy but not the particle. The particle will be vibrating in a straight line, right? So wave will not carry any particles, but it will carry only energy. Clear with this? So first, wave is nothing but it is a disturbance in a medium that carries energy without the movement of particles. It may take the form of an elastic deformation, a variation of pressure, electric magnetic intensity, or electric potential or temperature. Any energy may be carried out, but the particle will not move from one place to another. Okay, remember this. Next, concepts related to waves first. Before we study the actual waves, we need to know the concepts like wavelength, frequency, amplitude, pitch. All these things we'll study now first. So first, what is amplitude? So amplitude is nothing but it is a height of the wave usually measured in meters, and it is directly related to the amount of energy carried by a wave. So higher the energy, higher the amplitude. That means higher the amplitude, higher the energy carried by the wave. And what is the wavelength? The distance between the identical points in the adjacent cycles, that is crests or troughs, that is called wavelength. Okay, suppose if I take a wave, these two are called crest, right? And these are called trough. So wavelength will be the distance between two successive crests, that is lambda, or two troughs. Okay, it is also measured in meters. Next, periods. What is period? The period of wave is the time for a particle on a medium to make one complete vibration cycle. Suppose if I am taking one complete vibration cycle, this is called one period. It involves one crest plus one trough. Okay. So it is also measured in units of time such as seconds or minutes. Then what is frequency? Frequency of a wave is the number of waves passing a point in certain time. Suppose if I take 1 minute, how many waves are created in that? That means how many oscillations or vibrations. So frequency is nothing but it is a number of oscillations per second. That means per unit time. So again we can say it is a reciprocal of, the period is a reciprocal of frequency. Okay, so frequency is nothing but number of oscillations per second, which has a unit. The unit is hertz. Okay, so we can see this is a wavelength, these two are crests. We can also say like this, these two are troughs, the lower displacements. So this is also lambda. Then what is one oscillation? It is a number of oscillations. Frequency is the number of oscillations per second, which has a unit called hertz. Okay, this is the height of the wave, that is amplitude. Okay, clear with this? Moving on to types of waves. So what are the various types of waves we generally hear? So first we shall see there are many classifications of waves. The first is classification based on type of propagation of wave. Okay, so first on the type of propagation of the wave, longitudinal waves, transverse waves, and surface waves. Next, based on medium of propagation, mechanical waves, electromagnetic waves. How I am saying medium of propagation? Mechanical waves need medium like sound. Sound needs medium to travel. There is no sound in space, right? So sound is a mechanical wave. Electromagnetic wave doesn't need medium. Light will travel in space as well as in atmosphere, also in air, right? So like that we are classifying based on medium these two. These two are on the based on type of propagation. Now we shall see what is this type of propagation. The first is longitudinal waves. The particles of the medium vibrate parallel to the direction of the wave. So what is this parallel to the direction of the wave? Suppose there is a wave going like this. Hope you can remember, like, so it is vibrating parallel to this. That means, hope you can remember, if I draw a line, so it is moving in the parallel to the direction of the wave. So example is sound waves, P-type earthquake waves. We have seen in geography, earthquake waves, P-type, that is primary waves, secondary waves and surface waves. Compression wave, all these waves follow the longitudinal mechanism, that is the particles vibrate parallel to the direction of the wave. See, okay, clear with this? Moving on to transverse waves. So opposite will be the same. So the particles vibrate perpendicular to the direction of the propagation of the waves. See. Now in the next phase, so the particle A now here, it is here now. So it is the particles of the medium are vibrating perpendicular to the direction of the wave. This is the direction of the wave, it is moving forward, but the particles are vibrating perpendicular to the direction of the wave. Examples: water waves, ripples of gravity waves, not sound through water. Light waves, S wave, earthquake waves, stringed instruments, right? When I see a guitar, when I strike it, the string of a guitar, the particles will vibrate perpendicular to the direction of the wave. Torsion waves, right, a string tied to a thread. All these are the very best examples of transverse waves. Okay, next moving on to surface waves. It is a wave in which particles of the medium undergo a circular motion. So when I see any particle, it will make circular direction, though it is propagating in this direction, but the particle will make circular direction at the various positions of the wave. Okay, so very best example is ocean surface waves will follow the surface waves. If you see the particle, again it will come back. Suppose this is the original position A of a particle, again it will come back to its original position, like that. So this process will repeat. So example of longitudinal waves, very best example. This is the wave propagation. See the particle movement in transverse, it is perpendicular. And see the particle movement in surface waves, again it will make a circle. Okay, hope you are clear with this. Transverse wave, longitudinal waves and surface. Remember, longitudinal waves means parallel, transverse waves means perpendicular, surface waves means on the surface. Clear? Moving on to mechanical waves. So we have already seen the type of propagation, longitudinal, transverse and surface waves. Now we shall see the medium of propagation, how they are classified. So I've already told you mechanical waves require a medium. Okay, so example is sound waves, water waves. Sound cannot travel in space. Yes or no? So it requires a medium. Next, electromagnetic waves. It doesn't require a medium. Example, light rays, radio waves, microwaves, UV rays. They travel through space also. They can travel through vacuum also. Right? So moving on to sound waves. So in this topic we shall discuss the sound waves. So what is sound actually? Sound is nothing but it is a vibration or disturbance created in air. Suppose there is an object called, this is solid. I am hitting with a force F, right? So when this solid vibrates, so the air particles which touch this solid will vibrate and create a noisy sound that is called sound. So sound is not created without an external force, right, or internal force, right? Suppose a human body is making sound because of the internal force which is generated by the organs, right? So sound is a longitudinal wave. Longitudinal means the particles will vibrate parallel to the direction of the wave, and it is mechanical. It requires medium, right? Without medium, sound cannot propagate. Sound can travel through any medium, but it cannot travel through vacuum. There is no sound in outer space. This we know it. And sound waves are classified into three types: infrasonic, sonic and ultrasonic. What is this infrasonic waves? It's their frequency is less than 20 hertz, right? So examples: elephants, whales, hippos, rhinoceros, giraffes, they produce this infrasonic, and they can also hear this infrasonic. And these infrasonic waves are used to detect earthquakes, volcanoes, tornadoes, etc. Next, sonic waves. Their frequency ranges from 20 hertz to 20,000 hertz. This is a very repeated question. So sonic waves means which we can hear, which are audible to us. Humans, animals can hear clearly. Okay, and ultrasonic waves, their frequency is more than 20 kilohertz, that is 20,000 hertz. Okay, generally bats, dolphins produce these, as well as they can hear these waves. So clear about these? Okay, so moving on, how sound is measured. Sound is generally measured in decibels. Okay, so what is pitch? Pitch is directly proportional to the frequency of the sound wave. That means pitch is directly proportional to the frequency. Higher the frequency, higher the pitch. Suppose this is 1 minute. So in 1 minute there are some frequencies here. So if I see in the same 1 minute, this is higher frequency, right? So this is lower frequency and this is higher frequency. Higher the frequency, higher the pitch. Lower the frequency, lower the pitch. Okay, so high frequency sound is at high pitch. Women have high pitch. Don't think they have low pitch. They have high pitch because they have the higher frequency in very less time. And low frequency is at low pitch. Men have low pitch. Okay, moving on to music. What is music? It is a soothing sound to hear. Okay, and what is noise? Whichever is unwanted sound for us or animals, that is called noise. Okay, moving on to speed of sound. So speed of sound varies from different medium. It is highest in solids and lowest in gases. So solids greater than, liquids greater than gases. So speed of sound is in decreasing order from solid to gases. Remember this. So in air, it is very less. We have already seen in gases. How much is it? 331 meter per second in air. A very repeated question. A speed of sound in air is 331 meter per second. At 20 degrees centigrade in air is highest. So as the temperature increases, sound will also, its speed will also increase. So in liquids also it is more because it has to travel more denser things. Solids it will be highest. Okay, moving on to echo and reverberation. What do you mean by echo? What is a reverberation? What is resonance? These are some of the terms related to sound waves. So what is an echo? So now we will clearly distinguish what is an echo. Now you will not have any doubt on this. Okay, so first we shall see what is an echo. So echo means it is a repeated sound which is heard separately after a time gap of 0.1 seconds when it reflects by an obstruction or a mountain. Suppose this is a source of sound. This is making a sound. So it is traveling to a distance, there is an obstruction. Suppose there is a wall or mountain. So after hitting this wall, the sound will return back. Okay. So when it is reflected by an obstruction, it should be when it is reflected by an obstruction like wall or mountain, So first I have produced a sound. After a time gap of 0.1 seconds, I should clearly hear my sound. Suppose I say hello. So I should hear back after a clear time gap of 0.1 seconds, and the minimum distance between the source of sound to the obstruction should be 17 meters. Then only you can hear the echo. Generally we can hear it in near the mountains where the open spaces, right? Generally what we hear in a room is, it is not an echo, it is reverberation. Okay, we can clearly hear the sound as someone repeats. First I say hello, there will be a time gap, and then I can hear my voice back again. That is called echo. Okay, so what happens when these conditions are not followed? Then that is called reverberation. So when the time gap is less than 0.1 seconds and distance is less than 17 meters, then this will happen for reverberation. You will hear prolonged sound, hello, 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 like that. Okay, without any time gap. If the distance is less than 17 meters from the source of sound to the obstruction and the time gap is less than 0.1 seconds, then that is called reverberation. We hear repeated sounds. That is called reverberation. Hope you understood the difference between echo and reverberation. Moving on to, this is a diagram. See, echo, we can clearly hear the sound after a time gap, and reverberation, we will hear the prolonged sound gap. Next, what is resonance? So what is this resonance? So resonance is nothing but if the frequency of a vibrating object matches with the natural frequency of another, then the latter will vibrate with larger amplitude at frequency. So what is this resonance, right? Suppose there is a marriage barat going outside our home. So sometimes if the vibrating object, suppose anyone is in the marriage barat, we hear a lot of sounds, right? DJs. So in our house we have some plates or some tools like that, right? So if they match with that frequency of the DJ or the drums which were going on outside our home, the particles will vibrate and fall down or not? Have you observed at your childhood or now? Yes. So that is because of resonance. Soldiers marching on a bridge. So when the soldiers are marching on a bridge, they are vibrating, right? So if the natural frequency of the bridge matches with the vibrating frequency, then the bridge will start to vibrate and the bridge will collapse. That's why soldiers will not march on a bridge. They'll just go on their way. Okay, the bridge will collapse else because of resonance. Okay. So hope you have learned enough things on waves topic. We shall meet in the next sessions. Thank you so much.